Alright, looks like the stream is on. Good morning, guys. Evening, afternoon, wherever you are. Morning for me. Right, so today I will continue working with boid-simulation. And I was reading a little bit yesterday on how it should work. I was a bit busy at work, so I didn't stream, but nevertheless. I checked what we can improve, and as I was thinking, yeah, we need to improve. We need to add like spiral index, spiral grid, something like this. So we don't need to check every single. Right now I'm going through everything all on our screen, but I will split it onto cells, and we will be checking just neighbors, right? So I need to think about how it will actually work. Delete this for now and make them actually smaller. That's the aim for today, and then I had a ton of usage of squaring, rooting, and MassPo, because in Vector 3D we're doing quite a lot of that stuff, and I need to think about what we can do with it. I'm sure there is something we can do, right? So we're taking square root, we are putting into power of 2 quite often in normalize, and we trigger in normalize a lot. Yeah, so on every frame, on every... So once we add cells, it will improve already automatically that stuff, because we're gonna be doing less of normalization, calculations and stuff like that. But still doesn't solve completely the problem. Okay, so we'll have something like this. Alright, let me actually finish with the branches. I want to make it like separate optimization I'm doing in different branch. Actually, I'm going to start a timer. Today I'm going to be doing one 90-minute session. Feel free to ask questions, but yeah, when I'm coding, I'm not checking chat. Maybe I will check it, but I will definitely check it after the Pomodoro. All right. Delicious coffee. Merge. Let's push it. And we need to think how we're gonna do this. Alright, so we'll have a void. This guy. First of all, how are we gonna get cells? So we're gonna have yeah, pretty much this is the lengths, right? The entire lengths. Screen widths. We have cell widths. So we need to divide, right, cell width, screen width by cell width. This is the number of rows, right? Rows will be equal to that. The same for this stuff. This is screen height. And probably this is going to be the same. Then we need to assign to each and every one of them an index. So this is going to be 1, 2, 3, 4, 5. It's going to be 6, 7, 8, 9, 10, right? So we're gonna have in each cell, we're gonna have voids, right? So we need to have an array with cell index, and inside of it will be our void IDs, right? So this is going to be like 4, and here will be a lot of IDs. Now, how can we map to specific index? 11, 12. So let's assume we're this guy. We moved somewhere here. Okay, let's move to cell number 3. Let's do some cell number 8. He moved in here, right? We know his X and Y. So by dividing the entire screen by his X and Y, by his X, right? We will get these are rows. Yeah, this is column 2, row 1, row 2, row 3, column 4, right? And column 3. Actually, if we start from 0, right? I don't know why I did this. Right, we'll have from 0. This is going to be C1, C3. Right, so by dividing screen width by X, not by Y, not by X. What am I doing? By X, right? We'll get column. The same for row. We will get C2 R1. R0. How do we map into this? So we know that we are at C2. Times 5 plus R. Oh yeah, I'm an idiot. I started with 1. Should be, yeah, I'm thinking why it's not working. Yeah, so we need to, it should be 0, right? Okay, let's remove all of that. Okay, so let's clean it up. Okay, I think I got the idea. How can I make stroke smaller, stroke width and bigger? Yes, okay. gonna be, oh my god, index is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? This is R0, C0, C1, C2, C3, C4. This is R1, R2, right? So if we are in here, we'll get C2. Multiply it by 2 times 5. Nope. 2 times 2 will be 6, 7. Yeah, 2 times 2 plus 2. Okay, I need to write the code and see where I'm going with that. I just need to click it a bit. And I think I will figure it out. So essentially we need to map 2D array into 1D array, right? Yeah, I think I'm onto something. Right, so what should we do? We need to add the spiral. So we're gonna have our cells. We're gonna have rows. It's gonna be integer, cells, non-integer. And now let's do rows and colors, right? Probably cell size as well, integer. It's gonna be float 64. So we'll probably make the same as cohesion radius, right? So what are we gonna have here? So columns will be our mass cell. We're gonna have screen width divided by cell size. Same for rows. Not totally. We make integer. This will be rows times rows. Must be integer, or actually, yeah. I think this is it. We can remove this part. We'll have cell size, rows, Should I do this? No, I don't like this. Let's write a bit more code, but we'll avoid mistakes in the future. Right, we have our spiral grid. Now, what do we need? We need to be able to insert in it. Lean grid. And insert. Yeah, we need to provide void. Does it return anything? Probably not. Lean. Yeah, we need to get cell index. That's what I need to play around. And get xy. And integer. Okay. Yeah, so when we insert, IDX will be just S get cell index, B position X, B position Y, and then S cells index. This slice we have to append, right? And we allocate something in here. Okay, let's do it this way for now. And later on we will look the ID. We'll just append. Right, so this is the important one. We get the cell index. So column will be X. Wait a minute. Do we have X? No, Y? Yeah, I'm an idiot. Right, we just need to divide by cell size, right? X divide by cell size. We'll get here. Yeah. So column will be X divided by G. Correct? Yeah. I think it is. Y divided by S cell size as well. Right, so now we need to flatten it, right? So how do we get to number 7? Assume we're row number 1. Yeah, so we need to so it's R multiplied it by columns, by number of columns, right? Number of columns. So it's like row 1. We'll have 5 here, plus, and plus C2, plus, yeah, plus C2 plus essentially column, right? Okay, so if we're here, it's still gonna be 5 plus C3. We will get 8. If we are here, we'll get just 5 plus 1. Yeah, seems like alright. I mean 0. Okay. Yeah, that works. Should work. I hope. So we will have row multiplied by SG as rows. Should I name it SG? Like spiral grid automatically, right? I'm writing SG. Let's do it SG. Yeah, this must be integer. I think this is correct. Okay. Clean for range SG cells. So here I read about one trick. We'll just need an index, right? Cell I. Like we can do stream cells I. And if we'll do like this, we'll need to test it. So essentially we will keep custom, remove line. So we'll keep the memory essentially. We'll not reallocate every single time. So essentially we will have an empty slice, but with memory already pre-allocated to it. And in case we need to grow, we will grow. Right, what else we need? Yeah, we need to find neighbors. Right, so how is it gonna work? We are here. Probably I need to map through all of this, right? 3 by 3. If I'm here, I have only this 2, this 3, and me. I'm thinking about it now. Should we keep on boid his cell index? If the boid stayed in the same place as well. For example, I was here and I stayed in here. Okay. Yeah, but we are resetting everything. Okay, I need to think about it. Get neighbors. Thinking about as well, should we create like var results integer here and return it? Okay, let's for now remove it. Let's for now update the game. So in the game we have our SG, spiral grid, something we need to do later on. Size, yeah, probably cohesion radius. Now third beam. Dios, good morning. A lot of encouragement working. Wow. Well, I'm glad I can encourage. I feel like I forgot math completely, and this is very good for my brain. In web development, we don't do this. I mean, I don't do this at all. This kind of stuff. Something new. Alright, I will need to think if we need voids. Do we need voids even here? Okay, let's move on for now. So we are creating new void. It gets it x and y. Right, position x, y. Straight away add him into our grid. And we are starting jobs. Jobs will calculate acceleration, right? This part should be updated as well. Because right now, in calculate acceleration, we are going through everything. And here we need to provide neighbors. Alright, so it seems like we need to get neighbors first. Right, let's do. So we need to change how we update our logic. This is the first insert. Yeah, so in here, this is not going to be happening, right? actually remove this part from here. And we'll do update bg. Let's separate them. Oh. There's here. Right, do we have an update? Yeah, we need to update boids still. So here we'll say gym clean. So we will reset our grid on update. Here we need to insert them. Right. So in here we will calculate new accelerations. We'll get all the accelerations. We will update boid's acceleration. And here we will have a boid. This is already new x and y. We will just insert it onto fresh canvas. Something like this. So like here. Okay, now in here, I'm not sure if we should allocate new results per boid. Okay, let's do it anyways. I don't have any brighter ideas. We need to get a column, which we're in right now. This is going to be once again integer x divided by sg cell size. Should we provide entire boid? Yeah, I know. So we got current row, current column. Now we will need to, since we are taking 3 elements, right? So we start with -1 to 1. So we are here. -1, 0, 1, -1, 0, 1. We check all of them, right? Neighbor columns.
This feels, it's very soft. Very soft.
Right, and we need to do essentially the same thing. Neighboring rows. Now, yeah, so we are here. If we add -1, we will get here. If we add 0, we are still here. Yeah. Fire. add this like b call, b row, void column, void row. The actual one, the current column will be b column plus nc, and row will be b row plus nar, right? Yeah. So now we need to check all the possible scenarios when we are in corners, right? So in here, happened to my beautiful circle. So if column is less than 0 or row is less than 0, it's not gonna work. Or if column is greater or equals, greater or equals false, or row greater or equal 3 rows, right? Then we do nothing. Then we are outside of the screen. Otherwise, we need to get cell index we are in, right? So we are somewhere here, and we need to get all the voids which are in this cell. Essentially, we need to do once again. And we will be doing the same thing. Okay. Yeah, let me just take this part. Current cell index, is it correct? Okay. Now we will need to arrange over SG cells, cell IDX, and results, and V, like so. This is going to be boid IDX and boid IDX. Let's make it more explicit. Okay, I'll need to look into this as well, because we are creating results a lot. It's a lot of allocations. I feel like this can be done much better. Okay, let's actually do a bit of testing. Okay, let's have a look what we will have just by creating the game. Right. Let's reduce a bit boid size. Not 600. Let's make maybe 10. Nice. And let's make the screen size. Okay. We have 10 voids only. Okay. Got 13 rows. Let's actually as well test. Make reduce this size. Wait 20 rows. Change the track. Right, so we got XY 95, 96. Alright, amazing. Divided by cell size 0, 0. Yeah, so we are in the first cell. Good. Looks correct. Index 0. Right. These cells. We got 4 by 6. Alright. In 0, we got index 0. Good. Now we got x 340, 176. So it's 3, 1. Okay. Into 9. Is 3, 1. I have different grid. Right, my grid is 4 by 6. Okay. Okay. I'm gonna delete my beautiful drawing, just like we have to. This one's gonna go here. This is 10. Okay. We got X 40, Y 176. So y is 176. This is 340. Okay, I lost a bit track. Let's do another one. So x, 81 and 98. So 98 should be column 0 and 381 should be row 3, row 4, row. I do it. Oh yeah, other way around. Column row. Yeah. So column 3, row 0. Yeah, should be just index 3. This is easy one. Column 1, 0. Okay, why am I getting... Okay, now 5, 2, right? So we had 539 to... Wait. So we got 5. Yeah, so we got here and here. So index should be, what is it? 12, 13, 14, 15, 16, 17. Right? Yeah, index 17 makes sense. Right? Okay, looks good. Now we have all the boids, 10 boids. Two guys here. One guy here. Right, in general, looks okay. Make 150 once again. Like this. Okay, let's debug this one. See if we are finding neighbors correctly. Alright, what do we have? Oh. Yep, 600 items. Let's reduce to 10. Crazy. Okay, SG. We have 2 by 2. Well, that's a bit too small, right? But nevertheless, call row. Let's jump in here. So we have column 0, row 0, right? And we should get all of this into results. So 0, 1, 4, 5, 6, 7, 6 items. Let's jump here. So results, yeah. Pull out all of those. And in the end, results should have all of them. Right, makes sense. Okay. Let's change the fish size to, let's make it 100. So we'll have more cells. Right, our boid position 255, so it's 3, right? Cell size 200. Oh yeah, multiplying by 2, okay. So it's 1, 1. Alright, so we should get all the zeros. Yeah, I feel like that's small. Let's make it 50. Okay. Our void is at position 20, so it's 0, 1, 0, 1. Okay, good for us. So we should get, so we are here. We should get this, this, and this, this guys, right? We should get 0, 0. Who's in 0, 0? Nobody. Yep. Now from number 1 we should get index. In results we should get 0. Yeah, 7. Should get 7. On the 7th index there is no one. From the 6th we should get 0. Oh yeah, we got ourselves. And we should get 12 and 13. 12 and 13, no one. Alright, so result. We have only 2 items. Yeah, 0 and 7. Actually, okay, we are removing it later on. Let's append ourselves anyways. That's what we can do. Remove ourselves. Okay. So overall, the logic is working. I mean, we are finding neighbors. check how the clean works. Right, so we have SG cells. Let's add you to watch. So we have length 24, capacity 24, right? We have all these items. See, we cleaned, right? Length 24, capacity 24. All right, so we maintained length, we maintained capacity, but now everything is empty, right? These guys that were empty, now they are nil, capacity is 0. We maintain the capacity, so we're not going to reallocate. Well, getting neighbors here is pointless. Alright, I guess we'll have to measure how performant is that. Okay. In update, we're sending jobs. Let's get to our jobs. So now we need to get neighbors. Yeah. I'm not gonna provide the entire game here. Just gonna provide neighbors. Nope, we're still not. Yeah, on the game. I feel like this is it, right? So we are ranging not over everything now, we're just ranging over neighbors. Okay, let's see how it's gonna work. Right, the fish are swimming. Doesn't seem like they are swimming together, but let's make the screen back to a big one. Fish target size, cohesion radius. Let's make 200. Yeah, it doesn't seem like they're working together. I mean, I can see the fishes are pulling each other. Actually, my FPS even dropped. Let's increase cohesion radius. Okay, so clearly they're not working together. And look one more time. So like this fish, why is it not interacting with the others, with these two? Okay, maybe should be providing pointers. The worst part is that I didn't see improvement in FPS. I get like 60, 50, 70, 75. Okay. And commit the code. Check out previous branch. Well, okay, we have 60 FPS. I'm printing a lot, right? Copy it in logic. And 31. And then we are. Let's actually make just 10%. You know, this reduces FPS, but nevertheless. Right, so we have 60 on average, right? And we have how many boids? I have 600. I think in the other one I had way less, right? Oh yeah, I had 200. Oh, let's make 600. See what's gonna happen. Okay, so we're getting 70, 60. Not sure. So FPS is like 10%, maybe 15% better. Okay, then we're getting to stable 70. Previous one we're getting like 60. Okay, we're getting 80, 77. Alright, so performance FPS did improve. I would need to look at the memory. So cells are improving FPS definitely. The next question is why they are not cooperating, those lazy fish. Everyone is independent now. Okay, so probably I'm messing up something with pointers or whatever. How do we test that? Yeah, we need to let game run for a bit. The thing is that it's all in workers, right? In workers, and we are not returning anything. Okay, let's just place debugger there. One time check what kind of results we are getting. Then we will calculate acceleration. Yep, we have a breakpoint here. Then the big round doesn't matter. Maybe we are messing up something here. So we are removing everything from grid. Then we are setting new positions. I mean, we are calculating all accelerations. We add them into this acceleration array. Then we update all boid positions and insert them. Right, we update the entire canvas. Am I doing this in the wrong order? Okay. Let me think about it. Yeah, I feel like we need to... So on update, we'll have already voids with the newer positions, right? Then we calculate acceleration. Then we set next updates. Right? Am I right? And so... Alright, yeah, there we go. Errors has been found. Okay. So we have 70 FPS on average. 76. Good. Okay, let's have a look. What we will see. Alright, so we have old profile. Let's just store it. Old. Alright, so we can compare them. And yeah, let's take this one, 5 seconds. And we have a make file. Well, actually, let's test with race condition. We didn't test with race. Do we have race conditions? And bench time. Goodbye. Okay, we don't have race conditions. This is good. Now let's test it. This is actually very good. I think this is first try, no race condition. Okay, so go to up. Now we have top Cgo call. I'll assume this is a beaten. Draw RGBA. Top 20 cumulative. Let's see who is calling Cgo. Yeah, loop. Nice thread loop. So beaten is calling Cgo. Flash. There should be a way, I don't know, the tool. How can I view? We can just visualize it like this. Web. Can we do that? Okay, file cannot be accessed. Okay. HTTP. No. Oh. Thought it's gonna be different for CPU profile, but it's the same like for a lot of stuff in here. So what are the red ones? Runtime go call. Yeah, we saw that. Mass-po drop down by a massive amount, right? Previously mass-po was the biggest one. Now since we are checking way less voids, way fewer, it got much better. Right, so we have, this is a beaten stuff. Draw RGBA. Okay, let's look at, actually what is calling Go, right? Let's trace it back. Window, OpenGL graphics and graphics command. Red. Okay. Error group. Alright. Error group. And a beaten run game with options, right? Well, we don't have any options here, right? Unless write something ourselves, which probably will be a bit over my head at this point. Alright, user interface, update frame, draw game, new object, begin frame. Right, so this is the rendering. Spot buffers. So why do we need, if we are rendering everything here, what are we doing actually here? Run game with options. So this is update loop. Here we have draw game and update. And as I understand, frame creation. So why do we need, what are we doing in Go? Okay, let's ask Claude, just out of curiosity. Oh, all right. Yeah, OpenGL. graphics draw triangles. Is this because of that? Okay, I'm stuck with Seago. Let's close it for now. Right, I'm just like speedballing right now into AI. Maybe it will give me some ideas of how we can reduce Seago's. Because I have no clue, to be honest. Yeah, 42% goes into Seago. Looking at your profile, it will produce like a CPU draw close and be made too frequently. Draw image options eventually becomes an OpenGL call into Seago. The overhead is per call, not per pixel. So many small draws kills performance. Okay. Alright. Draw image. So, our background. Yeah, and we are drawing our voids as well. Okay, what if we will remove our background? Let's move it into separate function. G, G, override screen, just to see the difference. If it's our, well, we are drawing a lot of fish, right? Probably that's what's killing. But is there an option? I don't feel like there is a way around it. Right, so we removed draw BG and let's remove update BG. What else? Let's just see how it's gonna go. make run. Okay, so the FPS is pretty much the same without the background. Yeah, we can easily actually test. Right, sometimes FPS drops to 60. Like, I'm wondering why. I thought like background was like the major issue, but I think it's not. But yeah, like we can see that it's not. And make ideally my memory. I have like a fish memory for that test main. Alright. Yeah, it didn't change by much. Alright, so 1.4 seconds we are spending in Go calls. What if we drop the boids count to 300? The same. 146, so boid count does not affect. Okay, what if 100? Kinda doesn't make sense to me. So either AI is lying to me, $144, right? So the same. So the boid count does not affect. What if we make 1,000? Every 5 seconds is too little as well. But nevertheless. Yeah, 143. So something else. Lipsy. 20 cumulative. Loop flash. Loop render thread. Okay. Right, what else AI is telling us? Bit and draw image. Okay. Batch draw triangles. Do I do draw triangles? Not really. This is old stuff. Actually, we can compare it. Well, in my previous tests, Seago was using 041 and MassPo was like 135. So what the hell? Okay. Yeah, it's not added to CPU every frame. Is that VS Code? Yes, this is VS Code. Yeah, I felt like this is a problem. Compress not your decompressing juice frames at runtime. Have you tried Zaid? I'm loving it recently. No, I haven't. Maybe after Golang, but for now I'm learning Go. Still, long road ahead. Okay, so the issue is how I'm using a bit in library. Feels like it. So I started doing something that I wasn't doing previously. Image draw. Z not Zig. Ah, yeah, sorry. It's text editor. Z. No, I haven't tried it. Okay. Z is GPU acceleration, Rust. So that is faster. Workloads that's variables in the ship rate. Extension this code has unmatched extension access system. You see, extensions. Choose that of speed, minimalism, integration. You rely on specific extensive library extensions per. Is this fair? What AI is telling me? Because I have a lot of extensions, I'll be honest with you. Can I live without them? Yeah, I can. I have like a lot. Some of them are not working because, yeah, some of them, like I'm working sometimes on Linux, sometimes on my Mac, because I have to, not because I like to. But I don't know, like I don't have any problems with VS Code. I'm not like this obsessed person about editor, IDE. I know some people made like a whole careers on YouTube talking about the editors, but yeah, and I know why they are doing that, because they want views and all this kind of stuff on YouTube. But in reality, I don't know, at least in my experience, to me, it doesn't matter. What are you working on? Well, for now, a simple boid simulation in order to get better with Golang. What is boid simulation, you might ask me? It is something like this, when you have like a flock of fish or birds. Well, boid actually for birds. You see they're like swimming together, like fish do, right? If someone is turning, all of them are turning. Is this perfect? No, I will improve it, but for now I'm testing performance, see what can be improved, because I have two goals. I wanna play around with this kind of fish simulation. Later on we can turn it into game, where you can interact with this fish. Like either, I was thinking, either there will be like sharks swimming and you need to try to avoid them, otherwise the fish will be eaten, or we can make like gates and you have like a shepherd, or not for sheep but for fish, to push them into gates, and you will have like two players. So basically some silly game, but the goal is to learn Golang, and I want to test performance of this stuff, because as you can see I'm rendering right now 1,000 fish, and this is a good use case for like memory profiling, I think, CPU profiling, to see what can be improved. Like already we can see an impact of CGO. If I'm calling a lot of CGO, it's like my number one, right? Like 42% right now I'm spending in CGO calls. And I'm using Kafka with CGO. So I'm starting to think about it. That maybe Confluent in Kafka is not that good. I should test that as well. But overall, yeah, just studying, learning. Let's return our background because it looks a bit off without it. And yeah, I just want to do something fun for me. Looks fun, exactly. I was looking for something like is the fish upside down? I feel like they're swimming upside down. Yeah, this should be improved. Yeah, they're going from upside down state. So what I can do in terms of boid simulation, I can make like the front side to swim faster, so their like shape is not like they're all clamped up together right now. Are you using OpenGL? Yes, I am. But I don't know if I have options not to use it. Because what AI is telling me that since I'm on Linux, like I asked, can I use pure Golang, and he told me like no. There is no options. But I don't know if that's the truth. I'm completely clueless in this regard. Let's make 500 fish. Let's make it a bit bigger screen. Let's make even fish a bit bigger. Yeah, now when it's less fish, we can see how they are like starting to swim together. And my FPS dropped to 30. Wow. Probably because the screen, yeah, increased the screen size. Okay, that's quite enjoyable to look at. I'm not gonna lie. Like, I get it why people go into game development. Alrighty guys, I think I'm gonna be wrapping it up for today. In the next sessions I will continue testing performance and then we can improve the game itself. Are you on Fedora? No, I'm Ubuntu. Ubunting. Finished no. Spiral grid v1 create team go calls. Alright, let me go into boid's branch. I will merge this baby in it, so in case if you are curious. So I will be every optimization I will be doing in a separate branch, but there is boid's branch overall, in case if you want to follow with the latest updates. Hey, enjoy the rest of your day. Thank you, man. You too. Alright guys, everyone, thank you for watching. I'll see you next time. Take care.